Hey, 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 here to talk about sequences today. So if you need the review of this sequence page right here, that's what we're going to talk about. So first up at the top, you have your two formulas. The really nice thing is with those sequences, the formulas will be on your reference sheet. So if you have anything about a sequence, make sure you look there. And I've labeled for you what it stands for. So A1 is your first term, D is called your common difference, N is the term number, and we use arithmetic when we're adding and subtracting in our pattern. Now, don't let it throw you off if this difference is written behind the parentheses. It means the same thing. Over here with geometric, no division, only multiplication, but first term, ratio, and a term number for you there. So let's look at how these would work. Number one, first thing you need to do is find the pattern. They were adding 5 every time, and since they were adding, I know it's arithmetic. So I'm going to plug into this arithmetic formula up here. A1, the first term is 4. They were adding 5 every time. But this in green, I don't see, because it's not an answer choice. However, if I distribute that 5 right there, then I'm going to get this 4 and this negative 5 I could put together, which is -1, which is going to mean B is the correct answer. Now, if you go down and look at number 2, same thing. You're going to ask yourself, what is the change? It's multiplying by 3 every time, so it's geometric. First term is 4 times 3 n minus 1 times. Number 3 is a little different because they don't tell you what the change is. All you know is you start at 8 and the fourth term is 17. So you're going to have to guess around, do some guess and check a little bit to find out what the change was, but it ends up being that you were adding 3. So F1 in this function notation means first term, so I know the first term is 8. Well, they all say that, so I can't cross anything off. But the only answer that says anything about adding 3 is B. Okay, next, if you turn your page sideways to number 4 and 5, that's a 2, not a 0.2. But to get from 2 to 8 to 32, we're multiplying by 4. So this is just another way to say a sequence in words. To get the next term, I do 4 times what I have now. And number 5, kind of like number 3 we just did, except this time I know the change, but I know my fourth term is 108. If I know that I was doing 3 times to move ahead, then I'm going to have to divide by 3 to move back. So that's how I got these numbers in red. That tells me my first term is 4 and the common ratio is 3. So 4 times 3 to the n minus 1 is my answer. All right, let's flip to the back. So number 6 back here, you have to write a sequence and then you're going to plug in to it. So oh look, an announcement. The first term is 8, okay? The common difference is 3, so I just plug those into my formula. And then if I want the 9th term, I'm just plugging in 9 for n. I do PEMDAS and do my parentheses first. Then I multiply, then I add. I get the 9th term of 32. Or guys, you could just start at 8 and keep adding 3 9 times. Okay, number 7, given a sequence with a common ratio of 4. That tells me, since it has a common ratio, that it's geometric and I'm multiplying. So if the third term is 48, and I knew they were multiplying by 4 to move ahead, I got to divide by 4 to move backwards. So the first term is 3, and the common ratio is 4. Number 8, you're going to write the sequence here. You start with 1. Remember, this is my explicit rule. All this I've been using is my explicit rule, so don't let that throw you off. I start with 1. I'm multiplying by 4 every time, and it's geometric, so this n minus 1 is up there in exponent land. However, I don't see that answer choice, but because it's multiplying by 1, and when I multiply by 1, it doesn't change anything, I don't have to have the 1. So the correct answer is A. Don't switch your numbers and pick B. The 4 has to be with the exponents because it's what keeps happening. Number 9, you would just count the circles and see they're cutting in half every time. That's how you'd write that sequence, because remember, you can't put division in a geometric pattern. It has to be multiplication. Number 10 can be tricky if you don't read it carefully. They're subtracting 23, so it's arithmetic, but they ask you for the next term. That's why it's B and not A. Which sequence has a common difference? Common difference means it's arithmetic, so you're adding or subtracting. And since it's a positive 1.25, it means you'd be adding it. So B is the best answer. Number 12. Here is your pattern, 250, 255, 260. What's going on? You start at 250 plus 5 n minus 1 times. And lastly, number 13, if you want to know the 10th term, all I do is plug in that 10 for n right there. I'll do 10 minus 1 and get 9. A third of 9 is 3, and 3 plus 1 is 4. So hopefully that helps you know a little bit about sequences. Don't forget they're on the reference sheet, and you can use the formulas to help you. Have a great day.